So we've talked about solutions in the past, and we stated that solutions were defined as homogeneous mixtures. The relative amount of a component in the solution is known as the concentration. Solutions are made up of solutes and a solvent. A solute is the substance that is dissolved in the solvent. The solvent is the medium in which the solute is dissolved in. An example of this is powdered drink mixes, which would be considered your solute, which would then be dissolved in water, which is your solvent. You could also see this as putting sugar in your coffee. Molarity, which we denote by the variable m, or also molar concentration, is defined as the number of moles of solute in exactly 1 liter of solution. So molarity is a new unit to us, and it is the concentration unit. Because it relates the amount of solute in a specific volume of our overall solution. Molarity has units of moles over liters. Molarity by itself is a unit, but it is a derived unit, meaning it is made up of units of other types. So it's made up of mole units as well as volume units. If you know the moles of your solute and the total volume of your solution, you are able to find the molarity or the concentration of that solution. We can vary our molarity by changing the amount of moles or changing the volume of our solution. I like to give the example of, think back to when you were a kid and you were drinking Kool-Aid, and you had Kool-Aid mixes that you would put into a pitcher and add water. If you put the Kool-Aid in first and then added a little bit of water, let's go with fruit punch Kool-Aid and it's red. You added in just a little bit of water and it was a very, very dark red color, okay? And if you tried to drink it, it would be very, very sugary. So we had a lot of our Kool-Aid mixture and not a lot of liquid. Therefore, we had a high concentration of sugar and Kool-Aid in the pitcher. If we added more water to our pitcher, the 2 gallons that it asked for on the package, okay, we add more water, that color, that red color, is no longer dark, becomes lighter, and when we go to drink it, it actually tastes good. So by adding volume, by adding more liquid, okay, by increasing that volume, we've decreased our concentration. So it's less concentrated, it's less sugary when we drink it. So that's a good example of molarity in our daily lives. So we can calculate molarity if we know the moles of our solute and the total volume of our solution. Now what I want to point out are the units that we have to use. If we want to have proper molarity for concentration, we must have moles of solute and liters of solution. So in our example here, suppose a 355 milliliter soft drink contains 0.330 moles of sugar. Calculate the molar concentration of sugar in the drink. So we want to know the concentration of our solute, sugar, in our overall solution. We have our mole value, that's 0.330 moles. Our volume is given as 355 milliliters, but we can't use that unit. I should say we can use the number, we can't use that unit because we need our units to be in liters. So before we can solve this problem for the concentration, we have to convert our volume into units of liters. So the first thing we're going to do is take 355 milliliters, and we are going to convert that to liters. In 1 liter, there is 1,000 milliliters. So to convert that, all we do is take 355 and divide it by 1,000. And we get that the volume is actually 0.355 liters. Now that we have our volume in units of liters and our moles in units of moles, they were given to us, we can now solve for molarity. So molarity, M, is equal to moles of solute, 0.330 moles, divided by the volume in liters, which we solved to be 0.355 liters. So to solve for the concentration, we just take that mole value and divide it by our volume. And we get 0.929577 moles per liter. With sig figs, this would come down to 0.930. Okay, 3 sig figs, 1, 2, 3, 1, 2, 3. So we would stop here. That 5 would round our 9 up to a 10 or to 29 to 30. And our units for this, we can express molarity either as moles per liter, or we can write this as 0.930 capital M molar. Capital M is our unit for molarity. We want to make sure we're making a difference between little m, which is meters, and big M, which is molarity. Okay, so capital M is molarity, and yes, there is a big difference. So you want to make sure you're using the capital M. I don't want to say that I took moles and liters and somehow turned them into meters. That would be very confusing how we did that. So we have capital M. But because molarity is a derived unit, you could also write it as moles per liter. Okay, so that was an example of where we knew our moles and we knew our volume, and we wanted to find our concentration. Our next example is one where we know the concentration, we just defined it as 0.930 molar, and we want to find the moles in a specific volume of that solution. So if I know molarity and I know volume, I can also solve for moles. Okay, this is just one of those equations where if we know two of the variables, we can solve for the third using algebra. So for this one, we know the molarity, that's that 0.930. We know the volume, it's saying in approximately 1 sip, which is about 10 milliliters. So we have to solve for the mole value. Now again, we have to pay attention to our units. 10 milliliters will not work out. Okay, our units will not cancel if we used milliliters. So we need to convert 10 milliliters to liters. So again, we start with 10 milliliters and we multiply this by 1 over 1,000, because in 1 liter there's 1,000 milliliters. So 10 divided by 1,000 is 0.010 liters. Just keeping that extra 0 on there for sig fig purposes. Okay, so now that I have my volume in liters, I can now plug everything in and solve for my moles. So molarity is known. It's 0.930 molar. I'm going to write that molar instead as moles per liter so we can see how our units cancel. And that equals X number of moles. We don't know those yet, that's what we're solving for. And over our volume, which is 0.010 liters. So to solve for moles, we just have to multiply both sides by 0.010 liters. Okay, so that will cancel out there. And what will happen here is my liters are going to cancel. Let me show this in a different color. my liters are going to cancel with my denominator of my units of molarity. Okay, molarity again is a derived unit made up of moles and volume in liters. So when I take a volume and multiply it by the molarity, the liter unit cancels. And I'm left with a unit of moles, which is what I want my units to be in because that's what I'm solving for. So we take 0.930 and multiply it by our volume, and we get that our moles is equal to 0.0093 moles. With sig figs, this would be 0.0093 moles. So we took our known molarity and our known volume and used that to solve for moles. We could also do the same thing if we knew moles and knew molarity, we could solve for volume. Again, this is one of those equations where if you know two of the variables, you can solve for the third. So I want to introduce you to the molarity triangle. A great way to solve molarity problems is with the molarity triangle. When you have a molarity problem, all you have to do is cover up the variable you are solving for, and the triangle will tell you what needs to be multiplied or divided together. So here's our molarity triangle. A vertical line means multiplication, and a horizontal line means division. So if I wanted to solve for molarity, all you do is cover up the m, so we're solving for capital M, and so what you would do is take moles and divide it by liters because those are the only two left in the triangle. So moles divided by liters. The other example I have for you is the one we just did. We want to find moles from molarity and volume. Well, all you do is you cover up the variable that you're solving for. So we're solving for moles. We're going to cover up moles, and that tells us we have to take molarity, multiply it by liters, right? In order to get these two, I had to go through a vertical line, which means multiplication. So I covered up moles, and I now have to take molarity and multiply it by liters. And that's exactly what we did in our previous problem when we took 0.010 liters and multiplied it by our molarity of 0.930. We got out from this equation a mole value because this unit of molarity can be rewritten as moles per liter, where when we multiply the volume and the molarity together, the liter unit cancels and we're left with units of moles. The molarity triangle helps us remember what needs to be multiplied or divided in order to solve for molarity. So let's practice using that. Distilled white vinegar is a solution of acetic acid in water. A 0.500 liter vinegar solution contains 25.2 grams of acetic acid. What is the concentration of the acetic acid solution in units of molarity? Well, we know our volume from this problem. We, however, don't know our moles, but we do know our mass, and if we know the mass of a compound, we can find the moles. So before we can plug moles in, we need to convert from mass to moles. Now, using our molarity triangle, we want to find the concentration. That's uppercase M. So to find concentration, we cover up the M, and we say that moles has to be divided by liters. So once we find the mole value, we'll just take that and divide it by our volume, which is already in liters, and we'll be able to find our molarity. Okay, so let's start. Let's first convert our mass into moles. We have to convert first, okay? We can't convert later because then that wouldn't be the the correct value for molarity. So we take the mass, 25.2 grams of acetic acid, which I'm just going to show as AA, and to convert it from mass to moles, we need to use the molar mass. Molar mass has units of grams per mole. So in order to cancel out grams, I need to put the mass on the bottom and the 1 mole on the top. I can write that one better. There we go. The molar mass of acetic acid is 60.05 grams. We can find that because we have the formula for it, so we can just use our periodic table to solve for the molar mass, like we've done multiple times in our lessons so far. So we're going to take that 25.2 and we're going to divide it by 60.05. That way our grams cancel and we're left with units of moles. So that gives us a molar value of 0.41965 moles of acetic acid. Now that we have moles, we can solve for molarity. So molarity is equal to the mole value, 0.41965 moles, divided by the volume, which is 0.500. And all we have to do is divide those two numbers together. So we're going to take that mole value, divide it by 0.50, and we get a molarity of 0.839300 molar. We have 3 sig figs for our final answer, so this should be 0.839 molar for our concentration of acetic acid. Let's do some more. We have 2 problems here. We want to know how many grams of NaCl, sodium chloride, are contained in 0.25 liters of a 5.30 molar solution. Well, this one is similar to our previous example where we have volume and we have molarity, and we need to find, in this case, grams, but the only way we're going to get to grams is to first go to moles and then to grams. So we'll use our volume and our molarity to get moles out. And then we can use that to convert to grams using the molar mass of NaCl. Okay, and then the second problem says the concentration of acetic acid in white vinegar was determined to be 0.839 molar. What volume of vinegar contains 75.6 grams of acetic acid? So this is also similar to an example we did previously. So what I want you to do is pause your video and try to solve both of these problems using we have both of our equations for molarity and our molarity triangle here. So use both of those to help you solve these problems. Both the molarity equation as well as the molarity triangle are provided to you in your resources when taking exams, so getting used to using them now will help you when you go to do your homework and when you go to do your exams. So pause your video and practice these 2 problems. For our first example, using the molarity triangle, if we want to find moles first, before we can go to grams, we're going to cover up moles, and we say that the molarity needs to be multiplied by the volume. So that's our first step. We're going to take 0.250 liters and multiply it by 5.30 molar. Again, we can rewrite molar as moles per liter. So we can see that our liters are going to cancel, and we're left with see, 0.250 divided by 5.30. So we get, oops, not divided by, my bad, 0.250 times 5.30. There we go. And that will be a mole value of 1.325 moles. That's moles of NaCl, but I want to find grams. So to find grams, we're going to have to use the molar mass. If I want to find grams, grams will go on top, 1 mole will go on the bottom, and the molar mass of NaCl is 58.44. Again, we can use our periodic table to find that molar mass. So we'll take that mole value and we'll multiply it by 58.44, and we get 77.433 grams. With sig figs, that'll reduce to 77.4 grams of NaCl. Okay, our second problem, we have to, let's see, we're solving for volume. So we're going to cover up our volume unit now, and we say that we need to take the mole value and divide it by the molarity. Remember, a horizontal line means division. So we'll take moles and divide it by molarity to solve for the volume. So what we need to do first is find our mole value. We have our concentration, we solved for that in our previous examples, but we have a mass again. So we're going to do what we did before and take that mass of acetic acid and convert it to moles using its molar mass. So we have 75.6 grams of acetic acid, and we're going to divide it by its molar mass of 60.05 grams per 1 mole. So 75.66 divided by 60.05, and we get that our mole value is 1.25995 moles of acetic acid. So to find the volume now, we're going to take our moles and divide it by our molarity. So we'll take 1.25995 moles, divide it by the molarity we solved for, 0.839 molar. Again, we can rewrite molar as moles per liter. Moles will end up canceling when we do the division, and we'll be left with units of liters, which is what we want if we want to have a volume at the end. So we'll take that 1.2599 and divide it by 0.839. And we get a volume of 1.5017 liters. So when we divide moles by molarity, our volume unit is already decided for us, and it is going to be liters. If the problem asked for the volume in milliliters, then you may have to do an additional conversion to go from liters to milliliters, because molarity units are specifically moles per liter. Okay, so with sig figs, this would be 1.50 liters, 1.5 liters. Okay, let's do a few more. I want you to try these independently. I also don't have the molarity triangle on here, but you should have it in your notes. It's in your note pack. So utilize each of these to calculate the molarity of each of the solutions below. I'll give you a little hint here. I'll give you the molar masses for the 3 compounds, so you don't have to spend your time calculating those. So methanol is 32.04 grams per mole. Calcium chloride is 110.98 grams per mole. And naphthalene is 128.17 grams per mole. So those are their molar masses, so you can convert grams to moles and then use that to calculate your molarity. Remember, we have to convert milliliters to liters, and that in 1 liter, there's 1,000 milliliters. So use these conversions and pause your video and solve these 3 problems. The first step for each of these problems is to convert all of our units or all of our values into the proper units. So the first thing that we're going to want to do is take our masses, 6.57 grams, and divide them by their molar masses. We'll do one at a time. So 6.57 divided by 32.04. So we get a mole value of 0.20506 moles. We also need to convert all of our volumes into liters. So we have 1.50 times 10 to the 2 milliliters. There's 1,000 milliliters in 1 liter. So we'll take 1.5 times 10 to the 2. Oops, that's not a 2. That's a 2. And we'll divide it by 1,000. So we get 1.5. No, 0.15, sorry. Liters. Okay, and then to solve for molarity, we then just take those two values, 0.20506 divided by our volume. We get our molarity out, 1.36. That's what, 3 sig figs? There we go. So that should be 7 with rounding. Molar. 1.37 molar for our first one. For our second one, we're going to do the same thing. We're going to start with 10.4 grams. And we're going to divide by the molar mass of 110.98. So we get a mole value of 0.093710 moles. And for our volume, we'll just divide that by 1,000 again. Which is 0.22. Okay, so then for molarity, we take those two values, 0.093710 moles, and divide it by our volume, 0.22 liters. 3710 divide by 0.22 to get a molarity of 0.426 with 3 sig figs. Okay, and our last one, the same steps. 7.82 grams divided by the molar mass of naphthalene, 128.17. What is happening? 7.82 divided by 128.17. 061013. 061013. Okay, and our volume we just take and divide by 1,000. And we get that volume in liters. So we just take those two values and plug them in to find the concentration. So we take 0.061013, divide that by 0.0852. And we get 0.716 molar. Okay, so for these ones, all we did was convert from grams to moles, and then we converted milliliters to liters so that both of our values were in units of moles and in liters. Then once we had those values, we just divided them to find the molarity. For our next set of problems, we want to calculate the volume needed to make the following solutions. So I give you the concentrations as well as the masses, and now we want to find the volume. So again, I will give you the molar masses for each of these. NaCl is 58.44 grams per mole. And our second one, acetic acid, we did before, is 60.052 grams per mole. I did not specify what volume unit I wanted, so let's just go to liters and we can avoid the conversion. So let's get a volume in liters. So pause your video and try these two problems. For these problems, we're going to take a similar approach where we're going to start by converting our masses to moles using our molar masses. So we'll take 2.14 grams and divide it by its molar mass. So 2.14 divided by 58.44. Okay, once we have our mole value, then we just need to take our concentration and do molarity, moles divided by molarity, and that'll give us our volume. So if we use our molar triangle, we cover up the L, the liters, and we see that moles need to be divided by the concentration in order to solve for liters. So we will take our mole value, 0.036618, divided by the concentration given in the problem. Okay, and by dividing those, we get volume out. So we get 0.13563 liters. With sig figs, this would be 0.136 liters. If the problem asked you to convert to milliliters, then you would take it from there and convert it from liters to milliliters using our conversion. But I said let's stop at liters to avoid that. But just keep an eye on the problem on your homework and your exams on what unit they're asking for, because you may need to do some additional conversions. Okay, so the next problem we'll solve in a similar way. We'll take that mass, 0.85 grams, divide it by the molar mass, 60.052. And we get 0.01415 moles out. Now that we have moles, we can take our concentration and do our moles. 0.01415 moles divided by our concentration of 0.30 molar. So doing that, we get a volume of 0.04718, and that has units of liters. Again, just to show how our units are canceling, we have molarity, which is moles per liter. We have moles on top and bottom, so when we do the division, the liters will be left over. Okay. So with sig figs, this would be 0.047 liters because there's 2 sig figs in our concentration.